Okay, welcome back. So this time we're going to tackle Chapter 1, Section 5. This one is Rewriting Literal Equations, Part 1. Now, we're breaking into two parts because once we start getting into pre-existing formulas, it becomes a little more challenging, but not impossible. So let's look at what we've got. So the first step we're going to do is go to page 25, sorry about that, and we're going to write down a few equations and solve. Now, you need to pay attention to what the direction says. In the first 6, it wants us to solve for y. In 7 through 12, it's going to want to solve for x. So we're going to have to use a little bit of new knowledge and previous knowledge to make this work. So let's take a look at the first one. So for number 1, we have y minus 2x equals 15. And this says solve for y. So the important thing is to know what I'm solving for. If I know what I'm solving for, it's actually a walk in the park. So for solving for y, that means I want to isolate y. To do that, we need to get everybody else on the other side. So basically, it's the same thing we've been doing. So I'm going to take and add 2x across. Now, for those of you guys that are literal about adding 2x somewhere, remember, you're just tagging it on. So 2x plus 15. I did not add 2x to the 15 because we do not know what x is, so therefore I cannot combine it to the 15 because the 15 doesn't have an x. Now, another thing, you're probably wondering why I wrote the 2x first and the 15 last. Remember, in our equations, variables are going to come first, so keep this. I say remember because I want you to remember this. When you are solving equations, when you are removing or moving things around, your variables are going to come first and usually alphabetical. All right, so try to keep that in mind. I'll keep reminding you throughout the rest of this year as we go through. So there's our first one. So let's look at number 2. I want you to try number 2 on your own and then click back. So number 2, if you don't have the notes, is 4x plus y equals 2. So take a minute, pause the video, and then work through this one. Okay, hopefully you paused the video. So for number 2, what you should have done was subtracted the 4x across and then rewrote it as y equals negative 4x plus 2. If you got that, excellent job. If not, keep trying. So let's look at number 13. Number 3, not 13. So for number 3, the first thing we have to do is a little bit of legwork here. We want y by itself. So we're on a good path. We have the 5x minus 2, but on this side we have an 8, and then we have a 5 that's attached to it. So we have 2 steps. Let's take first and subtract the 8 across to get it away from that y. So I have 5x minus 10 equals 5y. Now, the second step is going to be divide everything by 5 to get y by itself. So I divide that by 5, and then each one of these on the left-hand side by 5. So I have x minus 2 equals y as my final answer. Okay, good job. Now try number 4. I'll put it on pause. So 4 and 5 are 2 of them I'd like for you to try before you restart the video. So take a moment, write them down, and then let's work through them. Okay, let's check in. So on number 4, you probably tell it was pretty easy. All you had to do is subtract the x over. So if you got that one, kudos. It was just like the last one we did with number 2. So we just took and moved it across. Now, number 5 was a little more complicated. You'll notice I did it a little different. Instead of adding the 4 across and having 3 terms on the same side, I took and did something a little different. I added the y across first. That way it was moved across to start the isolation. And then I took and added the 4 across so that the 3x plus 4 is on the left and the y was on the right. Now, folks, please remember that you can rewrite this at any point in time, which we talked about in the other videos. I could rewrite this to be y equals 3x plus 4. So simply just flipping them around. So the signs don't change, just the flipping of the two rebalances it. Now, last one, number 6. Let's walk through this together. If I want the y by itself, the first thing I'm going to do is subtract the 7 across. So I have 3x minus 6 equals negative 4y. Now this one I did a little different because I do not have the y isolated yet. It's still got the 4 attached to it, the negative 4. That's why I didn't just switch it across to make it positive. I was going to have to divide anyways, so I might as well go ahead and take care of getting rid of the negative when I divide. So the last step, like I just mentioned, is going to be divide by negative 4. So I have negative 3/4 x plus, because negative over negative, go ahead and reduce your fraction. That is going to become 3/2 equals y. And you have just completed the first 6 problems. Congratulations. Now let's focus on solving for x. So it says rewrite, in this case, solve for the equations of looking for x. I'm looking for x in this case. So let's look at 7 through 12. So for number 7 up here, I'm going to write to remind myself, solve for x. And this way it kind of reminds me what I'm doing. I have y equals 10x minus 4x. Number 8, we have q equals 3x plus 9xz. Number 9, we have r equals 4 plus 7x minus sx. Number 10, we have y plus 4x equals 10x minus 6. And we'll stop writing those 4 there. Now, each one of those problems have something unique going on. So let's start with 7 and work our way down. Number 7 is pretty straightforward. You have to combine those two there, which is going to give me 6x. Now, what you're probably thinking is, how, Ms. Kaufman, am I going to get x isolated when there's nothing on the y to divide it? Really, there is. Remember the invisible negative or positive 1 that we talked about? That's how we're going to do this. So we're going to divide both sides by 6 still. So I have 1/6 y equals x. So these are going to be more complex compared to the first ones. Now let's look at number 8. Number 8 has a lot of issues. So the first thing we're going to do is go, okay, I can't combine 3x and 9xz because the z is on the back of this. Now, we have not talked about the factoring. However, we have talked about distributing. So what we're going to do, we're going to start talking about factoring just a little bit. Factoring is saying, what did I distribute through to these two that are the same? In other words, what can I take out of both of them that is the same? Well, they're both multiples of 3, so we could take a 3 out. And they both have an x, which is how we knew that they belong together. So what this is going to look like, I'm going to rewrite the q. This is going to be 3x, parenthesis. When you divide 3x by 3x, you get 1. Plus 3 goes into 9 3 times. The x's are going to cancel out because they're the same, and then the z stays behind. So now you are almost done. I mean, you are so close. So what I'm going to do is this. I have to divide both sides by something to get the x by itself. Well, here's the kicker. Let's do this in one lump. If I want x all by itself, that means I'm going to have to get rid of the 3 that's with it and the 1 plus 3z that is with it. So if I have to get rid of those two things to get x by itself, that means I'm going to divide both sides by those two things. So your final answer is going to look like this, because these two are going to cancel and those are going to cancel, leaving x all by itself. So you have q over 3 parentheses 1 plus 3z. Yeah, that was a little complicated, I'm not going to lie. Let's look at a few others because you're going to see this again and again as a theme, so we might as well keep on plugging as we go through. Look at number 9. You're going to notice the same theme here. Once again, we have this little menagerie of a mess. I'm going to go ahead and subtract the 4 across first. So this is r minus 4 equals 7x minus sx. Yes, that's an s, folks. Now, just like we did with number 8, we're going to look at it and say, what does the 7x and the sx have in common? And by now, you're probably going, well, they have an x in common, which is correct. So if I pull out an x, that means I'm going to divide it both by x's. So they cancel. I get 7 minus s. And I'm going to recopy the left side here. Now, to finish this, all you have to do is divide by what they have in common. So they both have a 7 minus s. So your answer is r minus 4 over 7 minus s equals x. Yeah, that was kind of complicated as well. But keep in mind, one step at a time. If you need to, pause it and try number 10 now. This one's a little easier, but I still want you to pause it and try and see what you get. Okay, does your answer for number 10 look like mine? If not, let's go through. First step, the smaller of the two x's was on the left, so I took and subtracted it across and got 6x. I then went ahead and added my 6 to the right, or sorry, from the right to the left, which gave me y plus 6. Now, if you notice, I put a 1 in front of my y just so that I could visualize what the division was going to look like. And I knew it was going to be division because the 6 and the x were held by multiplication. So I divided both sides by 6. Now, if you notice from here to here, I actually took and wrote them as two separate fractions. 1/6 y plus 6 over 6 is the same as saying 1. All right, you think you got it? Well, now I want you to try number 11 and 12 on your own. Okay, for those of you guys that don't have the paper or the notes, let me put this up here because I know what's going to happen. You're not going to be able to do the problem without it. And remember, you are solving for x, nobody else, just x. So no matter how many variables you have out there, it's just x we are concerned with. All right, take a moment, pause the video, and see what you get. Okay, hopefully you've paused this. Here's what you ended up with. On number 11, I kind of showed it in 2 steps. I meant to do it as 1, got distracted. So I subtracted the 2r across. Let me show that there. And when I did that, I didn't really change it until that next step down here. So I have 4g minus 1r equals negative 2x. Now divide everybody by negative 2. Which, as you notice, I showed it like this, but then actually took it and went down here. So negative 2g plus 1/2 r equals x. On this side, I think this was easier than it looked. I subtracted the 12 across first, which gave me 3z minus 4 equals 3x minus 1z. I added the 1z across to the other 3z, and it gave me 4z minus 4 equals 3x. The last step was just dividing. So when I divided it, it created two fractions, 4/3 z minus 4/3 equals x, and we finished. All right, now we're on to the next stage, but what I want to do is break this into 2 videos. So I'm going to stop this one here and have you look for the part 2. The part 2 is going to be doing the formula side for the indicated variable. Not difficult, but once again, you have to pay attention to what we're solving for. Great job. Keep up the good work.